Okay, this diagram right here illustrates the situation. We have this boat at B that's 34 miles directly west of the city Uniontown, and the boat is traveling north at a rate of 41 miles per hour. Now, here's the angle opposite this side Y, and you can see that angle's changing as Y increases. Theta is getting bigger and bigger. And at some point in time, when Y equals 44 miles, we would like to know how fast this angle theta is changing. So we're going to set up a relationship between theta and Y and this 34 with this equation right here. The tangent of theta is equal to Y over 34, opposite over adjacent. And now we're going to take the derivative of both sides with respect to t. So the derivative of tangent theta is secant squared theta. Apply the chain rule because we're taking the derivative with respect to t. So times d theta dt. Over here, the derivative of y with respect to t is 1/34 times the derivative of y with respect to t. Okay, so there's our relationship. We can go ahead and solve for d theta dt by dividing both sides by secant squared theta. So here's our relationship right here. And at a given instant of time, when y equals 44, this little diagram illustrates the situation. Still 34 miles horizontal distance, this vertical distance has become 44 miles. And at that point in time, the hypotenuse using the Pythagorean theorem is the square root, 44 squared plus 34 squared. That allows us to calculate secant squared of theta. We don't actually have to determine what theta is. So the cosine of theta would be adjacent over hypotenuse. So the secant is hypotenuse over adjacent. Secant squared theta would be square the numerator, square the denominator. So this is what we're going to substitute in for secant squared theta. We already know that dy dt is 41 miles per hour. So there's your relationship right there. And if you simplify that and then do this calculation, I think you get something like 0.45 radians per hour. Okay, there you go. Hope that helped. If you have any questions, post a comment.